can also interact with the legend, so we can dim all the healthy tissue nodes and draw attention to the tumor nodes to give context to the tumor nodes without distracting from them or obscuring any of them. We have different color codings available here. We can do them by, say, their degree centrality. So in this color scheme, the squares represent the healthy tissue nodes that are not masked from the tumor, and we can click on them and gray them out and also reduce their size, maybe increase the size of the spheres, so you can really see the tumor regions in the context of which brain anatomy regions they're situated at. And you can also see how the different values of degree centrality spread across the different clusters. We can select some high degree centrality regions, see what other tumors and what other clusters they connect to. Looks like they're all pretty much connecting one cluster over here. You can change the color coding back to clustering and look at the same data again, so we can click on all of the nodes in a given cluster. See, this cluster seems to have a very high centrality. You can see how that cluster is oriented in the tumor's anatomy. So selecting all the nodes in one cluster on the left, we can see the network map of how a specific cluster, which kind of represents a cell type, seems like it has a presence in pretty much all of the tumors there. So that cell type is shown to be ubiquitous among all the tumors in this patient. I don't really see any tumors that don't have any of the cell type in it. The average path length, try to light up this whole cluster that contains the two nodes with the one of the shortest average path lengths. Well, that cluster is prolific, but this tumor here does not have any cells of that cluster in it. So that might be an interesting finding. Perhaps this cluster of cells evolved after this tumor was already established, and they have a founder mutation that this one doesn't have. Switch back to cluster coloring. We'll select all of these nodes again. That cluster is very clicky. It has a very high clustering coefficient. Most of the tumors have members of that cluster in it, have regions of this tumor does not. It contains only these clustered cells. You can highlight them and you can discover which cluster they are. They're all this cluster. That's the most ubiquitous cluster. So this tool could, on a imaging level, help plan biopsies to get a representative of all of the tumors with as little intrusiveness as possible.